So today we're going to be working with blocking. We're going to explain the purpose of it, obviously, first of all, and then we're going to design an experiment in block design or matched pairs. Which one's better, which one's worse, which one, that type of a thing, okay? So first of all, a blocking is taking a group of people or subjects So we're taking experimental units that are known before the experiment to be similar in some way as expected to affect the response to the treatment. Okay, so I'm going to pause it there for a second. And so what we're looking at, just kind of the funny example. So in say a pharmaceutical company, they have a new drug that's going to fix the hairy back syndrome. Okay, so what should be our experimental units? Do you guys, if you were to think about this, who would have, what do we want? There you go. Your experimental units are people with a hairy back. Okay. Now then I can break it up into regions, but I'm still looking for something that I'm choosing certain people or certain experimental units that has the thing I'm trying to fix. Okay. So then if we randomize, right, so randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. So if we have like block A and we have block B and C block, just like that. And then what will happen is we'll put the same number of experimental units in, let's just say 30 for the ease of it. Then we're gonna depending on how many treatments we have, remember the more treatments we have, the more confounding it's going to be. So we can limit our treatments, we're going to be doing better. So then if I come up here and say here's treatment A, here's treatment B, treatment A, treatment B, treatment A, treatment B, and if we tie in the stuff from yesterday talking about the double blind, meaning that people aren't going to always know what they're getting or the people giving the information or giving the medicine and collecting it won't know what they've received. Okay, so that's your double blind. So we can make this, as complicated as we want, saying, it's double blind, it's going to make it so people can't see into it. Okay, and then we're going to come into here. They do all their treatments, and then we come at the end. We collect the data, and then we report our data. Okay. Okay. Yeah, so the double blind was it's good stuff. I'll give you a second. Aspect here. Your blocking groups are not randomized. The subjects, or where we're looking at, not H, they need to be similar. If they're not similar, then you might as well just do stratified or a cluster. Okay. So then you break up into your blocks. That's how you do that experiment. Okay. Now, the cool thing is that one person will get the treatment, right? And then this one will say we'll get the placebo. All right. Now, what we're going to do, since nobody's online, is you guys get to play a little game. Okay. We are going to do an activity together. And then those guys at home can kind of see what happens to us. This is going to be called Get Your Heart Beating. And then for those that are home, it's on page 255. Okay, so I'm going to pause it and Okay, so we ran the experiment. We've gotten our two groups set up like we talked about here. This was our data collection, and this was our data dot plots. Okay, so besides our anomaly here, no offense, so we've got probably an outlier here. So in our report, we would say that this is an outlier here and focus upon this here. Okay. So real quick, what is going to be our mean? What's the easiest way to calculate the mean for both this one and this one? What would be the quickest and easiest way, guys? Technology. Okay. So we're going to pause it again. After eliminating our outliers, we find out that the mean is a 71 up right here and a 69.25 here. Now, since you guys did both experiments, we can do something but we can find the difference between you guys and kind of unify it a little bit more, right? Because even though our outlier is way out here at 140, if we just find the difference, that's just going to be about 5, right? And if we come into here, notice that if we start finding the difference up in here, that's an 8, there's a 4, that's a 7. Zane's data is actually going to fit into our outcome, right? So if I come back to I need to go back into here, and I need to record our student. Our subject 5, okay? Now, if I go to list 3, do I want to compare the difference of standing or sitting? And I believe we can do it either way. You guys can tell me what you want to do. You think standing's going to have the higher heart rate or sitting? Come on, CNAs, what is it? Standing. Okay, so my list 1 is standing, my list 2 is sitting. So I'm going to go with second list 1 minus second list 2, and there's my difference. Okay? Make sure I got, so that is standing 72, 75, 72, 73, 77. That one should be a 78. 77, 78, and 70, and then 65. And then, wait, no, that's on these backwards. That's 78. That one's 60. Oops. That one's 65. 78. 74. That's better. Second list 1 minus second list 2. Zane. And then I'm going to try it one more time. There. So if we look at our data set, now we're going to have a little bit more unified data where we actually can use our kind of our outlier. Okay. So we can actually compare data relatively easier this way. Okay. So the benefit of a matched pair is that you can compare allows the researcher to test both treatments on the same individual and look for the results. And then the matched pair, you can also just match them up, match individuals up that are similar, right? And I'm not talking just like identical cousins, but they have the same type of personality, they have the same type of body type, they have the same metabolism. You can do all those tests, and then you can run your experiment and match them up and see what happens from there. Okay. So that's matched pair. You're basically matching something up and you're pairing them together. We usually, I hate to say it, our focus will be on a simple random sample and then a stratified. Okay. So page 262, this is the last one for section 2. '86, and then 87 through 94, and that's your multiple guess. Okay.